Determine the sample size needed to construct a 99% confidence interval to estimate the population mean when the standard deviation of the population is 67 and the margin of error equals 12. And it says we can click on the icon to view a table of the standard normal cumulative probabilities. So we know that a 99% confidence interval, let's look at that. 99% be right in here, and 1%, which would be 0.5% here and 0.5% here. So we need the z-score all the way up to the upper. So that would be 0.5 plus 0.9. Actually, let's leave it as a percent and then change it to a decimal. So 0.5, so that would be 99.5%. So the probability we're looking for in the table would be 0.995. So we go to our table. This part is not new. We've been doing this for a while. 0.9995 would be in between 2.57 and 2.58. So 2.57 plus 2.58 divided by 2, because we get the average. So that would be 2.575. And I believe our z value, okay, they did use 2.575. They didn't round on that. So there is z. Now, we're looking at our formula here. We're going to square z, and then the standard error of the mean, we have to calculate that. Actually, no, it's the standard error squared, because we don't have n. We're trying to find n. So the standard deviation here, and I should have labeled everything. The standard deviation is 67. So we're going to times this by 67 squared. And then the margin of error is 12. They're going to give you that number. That's what we want the margin of error to be, and we need to know what n needs to be to give us that. So you're going to plug all that into your calculator, and you're going to round at the end. You're going to get 206.7, but we're going to round up. Regardless if it's a decimal, it says to round up to the nearest integer. Round up to the next integer, or basically round up. So 207 would be the sample size necessary. Okay, question 2 will be worked the same way. You have your table here. You really don't need it because we know that 99%, we just got the z value. It was 2.575. Question 3, you're going to work the same way. And it does say that it is advised to always round up with the sample size, because rounding down will not achieve the desired margin of error. So it's best to consider the stated margin of error as a minimum requirement. A smaller sample size is going to result in a larger margin of error. Question 4, instead of using the table, you're going to use Excel to get your z-score. All right, so let's look at this problem. Okay, so we are looking at a proportion here because we have P, and we're looking for a 95% confidence interval. So we're still going to use the normal distribution. if you take, we have the margin of error, and we're going to go ahead and assume that this is normally distributed. So in Excel, we're going to look up the probability. We're going to do the inverse. Remember, this is 95. So 5 on each side. 5 divided by 2 would be 2.5 on each side. I know I didn't draw that very evenly. So our percent would be 97.5%. So we need to look up 0.975. So we're going to do equal norm. And I'm going to close this over here. We don't need to see all of that. Okay, so norm dot inverse, and we want the one where all we have to do is put in the probability, norm dot s dot inverse, 0.975, and so your z value is 1.96. So we know that z is going to equal 1.96. So now we're going to plug in our formula. 1.96 squared times p, which is 0.37 times 1 minus 0.37, divided by your margin of error. We want our margin of error to be 0.05, and we're going to square that. So we're going to put that into our calculator, and remember, if we get a decimal, we're rounding it up regardless. And you get 358.1, so we have to round up to 359 so we can achieve that margin of error. Question 5, you will work the same way.